OpenAI just released GPT 5.5. It is their first fully retrained base model since 4.5, running on a natively omnimodal architecture. It features a 1 million token context window and can operate your desktop natively without needing external frameworks to click or type. But running it comes with a high price tag. On paper, the API cost just doubled to $5 per million input tokens and $30 per million output tokens. Meanwhile, Anthropic's Claude Opus 4.7 launched exactly a week prior, and it still holds the lead on critical coding benchmarks. We are looking past the marketing to evaluate these models based on benchmarks, actual token math, and hallucination rates. When one model leads on context, but another holds the coding crown, the choice stops being about which brand to trust. It becomes a question of which specific tool fits the task you're trying to solve. GPT 5.5's strongest area is what we call agentic doing. This is unattended command line execution and coordinating multiple tools without constant supervision. This chart shows the scores for Terminal Bench 2.0. GPT 5.5 leads at 82.7%, ahead of GPT 5.4, and leaving Claude Opus 4.7 behind at 69.4%. It applies that same execution to the desktop. On OS World Verified, it reliably navigates software interfaces to complete multi-step tasks. We are seeing this scale into massive enterprise environments. NVIDIA has already rolled out GPT 5.5 powered tools to tens of thousands of employees across legal, HR, and marketing. Hitting these completion rates requires a trade-off. You have to grant the model broad system access to let it work autonomously. If a workflow relies on DevOps orchestration or unattended automation, giving GPT 5.5 that access removes the need for constant human intervention. The math changes for developers dealing with IDE integration and heavy refactoring. This chart tracks SWE Bench Pro, which measures multi-file GitHub issue resolution. Claude Opus 4.7 leads here at 64.3%, while GPT 5.5 trails at 58.6%. That 5.7% difference is meaningful when you're relying on the AI to resolve pull requests and multi-file bugs correctly the first time. We also have the MCP Atlas benchmark, which measures how reliably a model chains multiple tools together inside a codebase. Claude scores higher here, suggesting it is better at maintaining logic across complex, chained coding scenarios. If you use GPT 5.5 for deep codebase refactoring, you may end up spending more time on manual PR reviews than if you had routed the task to Claude from the start. Then there is the cost. GPT 5.5 charges $30 per million output tokens. This chart tracks the actual per-task cost. Because GPT 5.5 completes tasks using 40% fewer tokens, the net price increase for developers is closer to 20%, not 100%. But reaching that efficiency requires an engineering investment. You have to rewrite your legacy prompts from scratch to work with the new architecture. Accuracy is the bigger concern for knowledge workers, who rely on factual reliability and long context retrieval. On the AA Omniscience benchmark, GPT 5.5 showed an 86% hallucination rate. It also struggled on the bullshit bench, a test that feeds models logically impossible questions to see if they push back. Instead of recognizing a bad prompt and rejecting it, GPT 5.5 often uses its reasoning compute to rationalize nonsense. It can synthesize a 1 million token document in seconds, but because it confidently defends incorrect assumptions, strict human oversight is mandatory for research workflows. The evidence shows that no single model is currently winning on every metric. This flowchart provides a routing blueprint based on the current data. It all starts with the specific nature of the task. If you need unattended command line execution, browser navigation, or multi-step tool orchestration, you route the request to GPT 5.5 for agentic automation. If the primary friction is code-based refactoring, IDE integration, or catching logical errors, you route to Claude Opus 4.7 for code-based precision. And for bulk processing of millions of tokens where budget is the priority, you route to DeepSeek v4. Implementing this requires building a unified API layer that allows your software to shift between these providers automatically. With benchmarks this divided, the goal is no longer to find a single all-purpose model. It's to have a stack that's flexible enough to use the right tool for the right task every time.